All right, so, oh, I do need the internet. So yeah, I have been learning. So who's seen me speak before? Okay, so then you know what's coming. I kind of want to apologize, but I don't want to apologize. Sorry, not sorry. You guys are the only opportunity I have to practice. So, Felcha Mocharchin, Ismisha Cory Agus Hami Aginsuka Gallic. Oh, it's not keeping up with me. Great. Let's do this. Every time I try to set up my speaker notes, and every time it never works. All right. Agus Anish Haukuchach. I got translations on the bottom if you guys aren't following along. She inle der bahar bok luk oprak ik omni ahanam hami ermoyoyevi and sho kolriev ula anju agus hami vidin sho tashbinachut. Why I avoid async await. So, a little bit about me, because this will become important in just a minute. I've been doing this for a hot minute, had a lot of experiences. It's not really important about what they all are, but it's important to know this is not my first rodeo. I do know a couple of things about this. You'll see why that'll be important in a little bit. But a little bit more than a year and a half ago, I wrote an article. Maybe some of you saw it. It's called Why I Avoid Async Await. I wrote it because I was motivated by what I saw as an industry leaving behind a very valuable thing in favor of something that was less valuable. Like every article I saw, every piece of documentation for software that dealt with asynchronous activity, all used drop promises like a bad habit, and we're using async await. Every article on Medium, they all were leaning heavily into this async await thing, and I thought that maybe we were doing this a little too hastily. It became vanishingly rare for me to see someone use actual promise chaining in their examples. So I wrote an article, as one does. I do. And actually, this one, it took off in ways I had never expected. It was amazing. I got a lot of, wow, this is just really slow for me. I got a lot of reads on Medium, and then one day, it just exploded. And I was super curious as to why that was, so I checked it out, and it's because it hit Hacker News. This is the first time I ever had anything hit Hacker News. It was amazing. And so, of course, I wanted to go see what people are saying about it on Hacker News. Here are some of the things that they were saying about it. They had thoughts, for sure. It was instructive, and I took them in, tried to understand them. Just let you consume some of this, feel some of my feelings, maybe. But all of this was fine. Honestly, all of this was fine. It was one in particular that really just set me off. And it was this one. And I kind of lost it a little. I had my own feelings. First some denial, some anger, some self-reflection, a little bit of doubt, for sure. Even just a little bit of depression. I'm not prone to depression, but I was down for a bit. Finally, some acceptance. Yeah, I was right. Maybe I came across a little strong in the article, so I thought that perhaps we could give this one more go with you guys. So, welcome to, in many cases, promises may make for a better pattern than async await. And I know even with this, this title, some of you maybe are, I'm in some hostile territory with you already with this. And rightly or wrongly, the burden of proof on my statement here rests with me. So let's start by setting a few expectations before we get into this. First, async await has its own benefits. We just won't be talking about them in this talk. And just to clarify some things that were apparently not clear to some people who read my article, yeah, I know async await is just sugar over promises. I know it's not a binary choice. You can use both. I'm going to be showing some examples. These examples are absolutely indicative of code I see in production written by smart, intelligent people. So this is not like cherry picking. I say that because, well, you'll see why I say that later in the talk, but it is important to me that when we're doing a comparison, when I'm doing a comparison, that I'm comparing things correctly. How can we make good decisions about things if we are just viewing straw man arguments on things? So I try very hard not to do that. If you think I've made a mistake and misrepresented something, please let me know. My point in this talk is not necessarily to persuade you to use promises over async await. It is really to get you, hopefully, to use your critical thinking skills and not just simply accept, oh, well, the rest of the community is doing this. Clearly, actually, that was one of the critiques about the article. Someone said, like, they clearly made async await for a reason. Well, that's not really an argument, my brother. So use your heads and use what works well, and think deeply about a problem. Don't just do it because other people are. I'm not saying async await is bad and that you should never use it. That's not this talk. Maybe next year. But this is you are probably dismissing promise chaining too soon talk. So let's talk about some of the problems I think come with async await. The first is that I think it provides the wrong, or actually more accurately mixed signals, and I'll show you what that means. It offers some bad incentives for the developer and the reader. It is an incomplete abstraction over asynchronous activity, and as I've kind of mentioned, a lot of the examples set up some pretty bad straw man arguments that I want to address. In contrast, promises offer clearer signals, better incentives. They are a single, complete abstraction over asynchronicity, and it can be a wonderful gateway drug to something delightful. We'll talk about that. So, but let's talk about mixed signals first. And not the signals that maybe you were hoping for, but that's fine. Very, very simple function up here. Can someone tell me what the function, how many truthy, did I get that right? I changed the name of this a couple times, so I'm going to make sure I got it right. Yeah, how many truthy returns? Is it 1? Or is it a promise of 1? It is a promise of 1. Why is it a promise of 1? But what about a line 3? I don't know about you guys. I look at a function, I want to know what a function returns, I look at the return statement. But with async await, we have to also look at the top. My function says it returns a length, the length of an array, but that's not actually true. I have to look at the top, see it, oh, it's an async function. It returns a promise of that thing. That is a mixed signal. There are 2 places I have to look in order to get signal to know what this function returns. In contrast, promises are honest up front about what they do. What does this function return in this case? It's very clear. It returns a promise. It says so right there. So, same thing, right? Okay, maybe that's not a big deal, right? We can manage this. That was one small example. Extrapolate that across like an entire code base. Maybe it's fine. Maybe you guys have lots of great experience with async await. Fine. You can manage the mixed signals. Let's talk about incentives. These 2 examples are very similar, but they both suffer from the same deficiency. What is it? Imagine this, we're taking this and we're going to ship it out to production. This is common code. I don't know if you guys have ever written this. I see this everywhere. Just a quick, go get a thing and parse it to JSON. What am I missing, though, that we ought to be doing? Loudly. Error handling, thank you. If we wanted to do this in strictly async await world, error handling looks like this. We need to completely refactor our function to wrap it in a try catch so that we can catch it and deal with it. With promises, it's simply adding a single line, a catch. These two are absolutely equivalent. They do exactly the same thing. One had to be completely refactored. Now, again, maybe that's fine. Maybe you guys want to take that on. No judgment here. Know what you're getting into, though. Now, of course, we're not there yet. All right, so async await, my point here is async await imposes a very stiff penalty, syntactic penalty, on error handling, something that we ought to be doing every single time. And as many of you, probably all of you know, if there's an easy path, most people are going to take it, especially when time constraints and product people are harassing us to get stuff done. Harassing is probably the wrong word. Encouraging us to get things done faster. We're going to cut some corners. We're going to miss some things. It just happens. We're human. Of course, like I said before, just because you're using async await doesn't mean you can't use promises. We can do async await with a catch in here. You kind of get the best of both worlds. This is fantastic, right? Who wouldn't choose this? We get to use async await and promises make things better. However, the thing you have to realize is now you're using promises, which you had to know you were using before, but you can't just be in this async await world. You have to also simultaneously be in this promise world. It is an incomplete abstraction. And this leads us to my next point, which we're forced into kind of thinking about two different things at once and using them at the same time. Maybe this is fine. It's certainly manageable in isolation, certainly manageable inside one function. But like I said, programming's hard, guys. And the fewer things that we have to worry about, generally speaking, the better. So my argument is, why take on unnecessary complexity? I know the arguments, by the way, I'm going to ad-lib here. I know the arguments, they say async await makes things easier, makes things simpler. You can think about your asynchronous code as if it were synchronous, except it's not synchronous, and this is the problem. You can't actually think about it like it's synchronous. It is asynchronous. You have to think about it that way. And so you have these problems that come up. We're going to take three examples here. We're going to have a synchronous version, an async await version, and a promise version. All right? In this version, the save function runs synchronously. Let's imagine we're saving to the local storage or something. Each of these run synchronously. The equivalent of this, using async await, and assuming now that this time the save function is asynchronous, looks like this. The promise version looks like this. Okay, there is a potential problem in the two asynchronous versions. Can anyone spot it? Not in this case. Yes, we should do error handling, but constraints of giving a talk and screen space. That's not the case this time. But we're going to ignore error handling. An optimization problem that potentially exists in both of the cases of the async await and promises. And that is, if you don't see it, the save function can and probably should be run in parallel, not serially. And we're running them serially. So we're saving, we're waiting till that's done, then we're saving again. But the two saves aren't dependent on each other. So we want to run them in parallel. Great. We can't run them in parallel in the synchronous version, so we're already done there. How do we do parallelizing of asynchronous calls in async await? Promise.all. We're back to promises again. So we wrap it into promise.all, and we do the same thing with the promise version, right? Promise.all. Great. Now everything's running in parallel, right? No, it's not. We still have a problem. Our async await version is still running serially. Do you see why? Because we're still awaiting those things. It turns out if we're using async await and trying to run things in parallel, there are cases where we should not have the await keyword in front of an asynchronous activity. We take them away. So, again, if you're using async await, you can't just think about it like it's synchronous. You have to think about it like it's asynchronous. Because if you don't, you run into problems like this. That would be if you look at the code, and for a few minutes, you can see it. But imagine a code reviewer, imagine you're writing on this thing, and you just type in. If you glance at that, it's not going to be obvious to you that this is problematic, because you'll think, that's an asynchronous, save is asynchronous. Of course we have an async next to it. But that's wrong. So context switching within the same code space is just one more thing we have to manage when we are dealing with async await. Promises, however, are a complete abstraction over asynchronicity. We don't have to think about using something else when we're dealing with promises. It's always and can always be promises. One less thing to have to context switch on. Okay. Now, let's talk about straw man arguments. Am I going too fast? Do I need to slow down? I feel like I'm spewing it out. Okay. Straw man arguments. Let's take a look at this. I got this from, you can see at the bottom there, from javascript.info. It is very representative of the kinds of things that I see. I figured this is the closest thing I could get to like an official something. In this javascript.info website, there is an assignment where they teach you JavaScript. That's the whole point of this. I have an assignment where we have this old and busted JavaScript or promise version. The assignment is to create it, to turn it into async await. So here's the assignment. The solution, according to the website, looks like this. Now, I have some problems with the assignment, and I have some problems with the solution. I don't think these are good, either of them. They're kind of terrible, in my view. So I don't think they're a fair comparison. I mean, I guess you want to compare crappy implementations with crappy implementations, fine. But I want to see what would actual code that I would write look like between the two. So I refactored. Here's how I would write the promise version. I really like me some expressions over statements, so I'm leaning heavily into expressions here. This is exactly how I would write it. And my solution looks like this. Both of these, in my view, are improvements upon the previous. However, in my view, the first one is preferable to the second one. Again, my view. Better, at least it's being honest on this one. However, they're not strictly the same. You see, in our promise version, and this is incredibly common when you're doing promise chaining, we are rejecting not with the string, the status string. We reject with the entire response because we want to know why it rejected. Maybe it's because the status was 500, or maybe because the status, maybe it's because we do something ridiculous on the back end and respond with a 200 and an error property on our JSON, which I have worked in environments like that, and so we need to understand what happened. So we rejected the whole promise or the whole response. Versus what is common with async await, we throw an error. That's what we do with async await. And when you construct an error, you pass it a string, right? So we pass it the response status string. These two are not equivalent. One has more information than the other. If I am dealing with an error, personally, I'd rather have the one with the more information to know what to do. However, we could take a page out of React's handbook, the concurrent stuff, and we could actually throw not an error. We could throw the response. We could do that. That works. But many people look at that and be like, bruv, what are you doing? That's so weird. I don't like it. It's unfamiliar. But, whatever. You guys make your own calls. This, at least, the two are equivalent now. You guys remember this from earlier? One of the comments on the article I wrote. This is a direct quote. When I read that, my reaction was something along this line. I don't know what they're getting at, because while I would agree with them very much that the top one is way better than the second one, they're also not remotely equivalent. I don't know where they're coming from. Clearly, this person has no idea how to use promises, like at all. So let's fix this for them. The assignment was to turn this into this, but in reality, it's this. Now, which one's better? I mean, maybe you still like the async await version, but you gotta admit that gap has been closed, right? These two are equivalent. So maybe, well, never mind. I'm not gonna be too bitter about it. That's fine. We helped them out. Congratulations. We fixed your problem. Now I want to give you guys a really real world example. I lifted this straight out of our code base, sanitized it, rejiggered it so that we don't have any proprietary or any information there, but maintained the what it does, right? The idea of what it does. It's not important what you see in here, like the actual code. You can kind of take it in broadly, but what is important? This code does 5 things. It validates the form, formats the form data that it gets. It creates a new database entry if it needs to, and we'll see how that works in just a minute. And then updates local state to reflect that, and finally it shows any errors that may need to be showed. So this is a mixture of both async await and promise chaining, and it's a bit of a mess. No one person wrote this. It was just something that happened. This is how things happen. So I went and I cleaned it up, like fair comparisons, right? Let's make sure we're comparing apples to apples. I cleaned it up so it's just strictly async await, and I made it as clean as I could. I'm trying to be honest here. And we were actually able to move it down from, 64 lines to 58 lines. So, not bad. I like shorter things. If we move this over to using promises only, we're now at, 40 lines. So not quite half, but close to half of what it was originally. Just taking it in broadly, obviously you can't read this, but this seems like this is probably going to be a better solution. Let's zoom in a little bit. This is the promise version. Every then that we do is isolated. It's in its own scope. It has input and output. The output of the previous then is the input for the next then. We can step through each of these thens one by one. We can do this because we can focus on one of those, and we don't have to worry about what came before, and we don't have to worry about what comes next. We can understand this in isolation. Each then can be considered by itself. No need to understand the whole to understand the part. No need to understand the part to understand the whole. Part 2, second step, this is the form validation stuff. We get our data. I probably, if I was writing this from scratch, I probably would have written this completely different. I just wanted to take what was there and show you guys, so don't judge too harshly on anything. I mean, whatever. It's production code. It's not real. We create an object. That's all that's going on here. We're just creating an object. It's got a formatted investee, investor, headquarters for each of those. Not a big deal. Here, we are making decisions. Either we don't need to create a database entry because we already have an ID, one has already been created, or we don't have an ID, and we don't have one because we don't have it in the database yet, so we need to go create one. That's all this does. It's two pretty simple little ternaries. If we have an ID, move along. If not, go create one, and then move along and update the state. And finally, maybe finally, almost finally, oh yeah, assuming everything goes well, we submit, and then finally, if there were errors in our catch, then we can display them. This, like, going through this to understand what's happening, one step at a time, one then at a time, this is chef's kiss right here. This is great. We don't have to think about everything all at once. Thank you. Furthermore, there's no code branching, and ternaries don't count for code branching. Whether that's true or not, that's my statement I'm making right now. Of course, you can have code branching, but with promises you don't have to. It's easier to not to than without them. There are ways of doing no code branching in regular old outside of a promise JavaScript, but it requires tooling and it's not trivial. So why would someone not want to write? Why would someone want to write stuff like this? Why is non-code branching useful? It's not because of, according to the internet, some esoteric performance optimization thing about compilers and whatever. I don't care about that. It's not important. It's JavaScript. That's not what we're worried about. I think it's important because it helps your code read linearly. It's like the difference between reading a novel and a choose-your-own-adventure book. And if you were trying to explain the plot of the novel, you can do that. If you're trying to explain the plot of a novel of a choose-your-own-adventure book, am I too old? Is that an old reference? You guys know what a choose-your-own-adventure book is? Okay, good. Try to explain the plot of a choose-your-own-adventure book. And you're like, well, it depends. It's like 5 different plots. Depends on which one you choose. And that's kind of what code branching does. This, you could say, oh, it's this, and this, and this, and this, and this, and it just goes like this. And it's great, and it's way better than having code branching. One last thing. I legally obligated to display this. Promises. Oh, I have this out of order. No, I don't. I just didn't go down. Functional programming. Promises are educational in the direction of functional programming. They train our brain to think that way. Promise chaining is similar in kind. It's not the same thing. It's similar in kind to functor mapping and pipelining. If you don't know what that is, come talk to me later. I'm happy to talk to you about it. Promises are instructive in understanding monads. Monads are phenomenal. And if you don't know what they are, come talk to me. I would love to talk to you about monads. So to sum up, promises give you clearer signals, better incentives. It's a single, complete abstraction over asynchronicity and helps you learn functional programming like kind of on the sly. So, use them. Hami and Dokas Kumbi Lama Live. Tapa Life.